The Dozels, it might be. I know he's in his face. So.
He just got his refresh. Could be his.
Yeah.
I don't know if it's just the two.
high.
I don't know if it's just the two. Maybe it's his face.
Or was it like a
Walk past
bullet
there,
train
I can
in
check.
there?
No, this
Always
definitely white
ignore
one.
I'm gonna lose it
It's not
if that's
like
the
a bullet, it's like a
case.
small one.
Okay, we're actually, let's just we'll do one example and then move into the problems. Oh my gosh.
What I'm saying is we just get a bunch of white.
Okay.
That will be done earlier this year, like orange.
Okay, so this problem is an open top box with a square bottom and rectangular sides. Has a volume of 72.
Gosh, I can't.
I feel I remember getting these. These are the questions you get on like the standardized test and I was noting.
It is constructed out of two different materials. The cost of the bottom is $40 per meter squared. And the cost of the sides is $30 per meter squared. Find the dimensions of the box. That minimize the total cost.
What are the slashes?
Per. An open top box with a square bottom and rectangular sides has a volume of 72 meters cubed. It is constructed out of two different materials. The cost of the bottom is $40 per meter squared, and cost of the sides is $30 per meter squared. Find the dimensions of the box that minimize the total cost. So the first thing I like to do is I like to draw a picture. That just usually helps me a lot. So I'm going to draw as best as we possibly can. Oh, not working. A rectangular prism or a box.
Isn't the bottom supposed to be square?
The bottom is square, so that means this side and that are both the same length. So I'm going to label those as a side S or length S. And then the height, we don't know either, so I'm just going to say that my height is H. So I have a length of S, a width of S, and a height of H. What am I trying to optimize in this problem? The cost. Which means I need to have an equation that calculates that cost. So of course my equation is going to be C equals something, you know, because cost. Are we good? When we break this down, I know that it is $40 per meter squared for the area of my base, correct? So how do I find the area of my base of this box? Or what is the area of the base? Which is the bottom of the box. So what is it?
S times S.
S times S, which is S squared. So it starts with 40 S squared. But that's not the only thing that makes a box, correct? We also have the sides. How many sides do I have? 4. So I know whatever one of my sides cost, I'm gonna have 3 more just like it. So 4 times 30 times, how do I find the area of each of my sides? SH, because it is the length of one of the bottom, and then the height. So now this is my optimization equation, 40s squared plus 4 times 30 times s times h. Can I do anything with it the way it is right now? No, I have to get it down to one variable. So do I have another equation that I could manipulate to get it down to one variable? Okay, I have volume. It told me that the volume of this box is 72. So I can use that to write another equation and solve for one of my variables with it. So we know the volume of a box is length times width times height. Well, here my length and my width are both s, and my height is h. So 72 equals s squared h, right? Length times width times height. Which variable do you think is going to be easiest to solve for? The h. And what am I going to do to solve for h? How do I get h by itself? By s squared. So h equals 72 over s squared. I'm going to take that and I'm going to plug it into my optimization equation. So when I do, I get 40s squared plus 120s times 72 over s squared. Of course, I would like to go ahead and simplify this as much as I possibly can before I try to take the derivative. Is there anything I can simplify in the first term? No. What about in the second term?
The 120 multiplied to the top.
I can put the whole numbers together, so the 120 and the 72, and then what can I do with the s's, Liam? Right, so the 1 for my numerator is going to cancel out one of the ones in my denominator. So then this becomes 40s squared plus 8,640 over s. Of course, I don't like to have fractions if I don't need to. So I'm going to rewrite this, bringing that s from the denominator up to the numerator with a exponent of -1. So this becomes 40s squared plus 8640 s to the -1. Are we all okay with that? Anything super crazy happening there? So what do I need to do next? Find the derivative. Brock, what will be the derivative for that optimization equation?
80s. 8,640 -2.
That's it, right? Because derivative of s is just 1. So 80s minus 8640 s to the -2. Oh boy. I typically don't like to leave it like that when I set it equal to 0 because the negative exponent kind of messes with us. So this is the same as 80s minus 8640 over s squared, or yeah. And then that gets set equal to 0.
Thanks.
I'll move it up. We're actually almost done. It's not really too much farther. My goal is to get s by itself, right? As I'm looking at this, is there anything that I could do to make this a little bit easier to work with?
Subtract the 80s.
Before even that,
When you subtract the 80s over and then multiply the s squared.
I'm going to go the opposite direction. I'm going to add this second term over to the other side to make it positive, and then I can manipulate across the equal sign. So then this becomes 80s equals 8640 over s squared. I would like everything on one level, Corbin, so what am I going to do next?
Multiply the s squared over.
Over to the left, right? So when I multiply it over, I get 80s cubed equals 8,640. I want s by itself, so what do I do next? divide by 80. I thought I heard add. I was like, no, let's not. So I divide by 80 and I get 108. And then what do I do? Cube root that. And what do I get for the cube root? Calculators.
My calc so far.
You do 108 to the 1/3 power.
6.48.
I got 4.7.
4.66, that's right.
Okay, I got 4.7622.
I got. Oh, well, it would probably help if I didn't put 103 to the 1/3 power.
What'd you say, hon? Oh.
Okay, 4.7622.
Okay, that's what I got. Everybody else get that?
Yes.
What was my problem asking for as the final answer?
Dimensions.
Dimensions.
Did I find the dimensions?
Found S.
The top ones don't have that. I found S, but I still have to find H, right? Because that's the other part of my dimension. So how am I gonna do that? Plug S into what? The 72 over S squared equals H. I have an equation already solved for that missing variable. All I have to do now is plug my answer in for the variable I have and solve. So when I do that, I get H equals what?
I'm not there.
Okay.
15.11.
That's 3 points. That's 3.1748.
That's much better.
I forgot the square.
So 3.1748 and 4.7622. Those are my dimensions, which would minimize the cost for a box with a volume of 72. Questions, concerns, or issues with that? How we feel about that? Overly difficult, long, I do agree with that one, but it's not too much to handle, I don't think. Right?
I think just figuring out how to make an equation.
Right, and that really just comes with practice.
Yeah, so manipulating equation.
So what I'm gonna do is I'm gonna put the first practice problem up on the board. I'm gonna write it for you guys, and then I'm gonna go and post it on Canvas so you guys can finish working through them, okay? So,
So are we doing the first problem on this?
you do on paper, because I do wanna grade these.
Whoa.
I didn't say how I was grading them.